What if I told you that 76% of companies claiming to have smart factories are actually missing the point entirely? They have bought expensive robot, installed fancy screen and hired data scientists, yet they are still not seeing the promised return. The problem isn't the technology, it is a fundamental misunderstanding of what a smart factory actually is. Today I'm breaking down the truth about the smart factories and showing you how companies of any size can start building one without breaking the bank. The insights I'm sharing have helped my clients achieve 31% productivity gains and over 43% quality improvements. And they are simpler than you might think. Hi, I'm Nikhil Pal, and over the past decade, I have led smart factory transformations across electronics, pharmaceutical, and medical devices manufacturing companies. I have seen firsthand what works and what doesn't, and how even mid-sized companies can leverage this principle without the massive investment you hear about in the case studies. The frustration I hear from operation leaders is always the same. Everyone is talking about the smart factories and Industry 4.0, but nobody explains what it actually means for my business. They are bombarded with technical jargons and vendor pitches, each claiming to be the silver bullet. In this video, I'm cutting through the hype to show you what a smart factory really is, the core technologies that power it, and most importantly, how to start building one in practical, incremental steps that deliver immediate values. So let's start with that, what a smart factory actually is and what it isn't. A smart factory isn't simply an automated factory, it's a connected, intelligent manufacturing ecosystem where physical production systems are integrated with digital technologies to enable data-driven decision-making in the real time. The key word here is ecosystem. Many companies make the mistake of focusing on isolated technologies, buying robots or installing sensors without creating that connectivity that makes these investments truly valuable. Think of it this way. A traditional factory is like your old flip phone. It makes calls and maybe sends text, but each function operates independently. A smart factory is like your smartphone, an integrated platform where apps communicate with each other, creating capabilities greater than the sum of their parts. The smart factory has four fundamental characteristics. Number one, connectivity. So machines, systems, and people are connected and communicating. Number two is the visibility. Real-time data is available and accessible to decision makers. Number three is predictability. Advanced analytics enable forecasting issues before they occur. Number four is adaptability. The system can adjust automatically to changing conditions. What's crucial to understand is that a smart factory doesn't require rebuilding your entire operation. You can develop these capabilities incrementally, starting with your most critical process and expand from there based on the demonstrated value. Now let's examine 5 key technologies that enable a smart factory and critically how they work together. So the number one is Industrial Internet of Things, which is also called IIoT. This is the foundation connecting machines and equipment through sensors that collect real-time data. But here is where companies go wrong. They install hundreds of sensors without a clear plan for how to use the data. If I share real-world example with you, a mid-sized electronics manufacturer I worked with started with just 12 strategic sensors on their critical bottleneck process. Those targeted sensors delivered a 28% OEE improvement in just 90 days because they focused on the right data, not just more data. The number two is the Manufacturing Execution System, popularly known as MES. This is the digital backbone that connects your ERP systems to the shop floor, tracking production in real time. Many companies either over-customize their MES, creating a maintenance nightmare, or implement it without adapting their workflows, means creating a parallel system. So what's the right approach? So the right approach is start with standardized process first, then digitize. Technology accelerates good processes but amplifies bad ones too. Number three is cloud computing. The cloud provides the scalable infrastructure to store, process, and analyze the manufacturing data. The mistake here is treating cloud migration as purely an IT initiative, not an operation strategy. So the success factor for cloud computing is to create the cross-functional teams with IT and operations working hand in hand to develop use cases that deliver operational value. And the fourth one is artificial intelligence and machine learning. These technologies identify patterns in your data to enable predictive quality, maintenance, and optimization. Companies go wrong by jumping straight to advanced AI without establishing data quality foundation. So the smart approach here is to begin with simple statistical analysis that drives immediate decisions, then build towards more sophisticated algorithms as data quality improves. So number 5 is digital twins. Digital twins are the virtual replicas of physical assets and processes, allowing for simulation and optimization. The mistake is building a complex model that required a PhD level expertise to maintain. So the practical way to begin is to start with the simple process twins of critical equipment or workflows before expanding to full production lines. Remember, a true smart factory integrates these technologies to create new capabilities. It is not about having each technology in isolation, it's about how they work together to enable a better decision making. Now let's bust the 4 most damaging myths about the smart factories that prevent companies from getting started. Myth number 1. Smart factories require full automation. The reality is, smart factories are about augmenting human capabilities, not replacing them. The most successful implementation I have seen is to maintaining the human at the center, using technology to eliminate the routine or the boring task and enhance the decision making. Myth number 2. Smart factories are only for large enterprises with massive budgets. Reality is, the size doesn't matter, maturity does. I have seen small to mid-sized manufacturers with more advanced capabilities than Fortune 500 companies because they focused on solving specific business problems incrementally rather than boiling the whole ocean. Number 3, smart factories require replacing all legacy equipments. Reality is, most legacy equipments can be connected to your digital ecosystem with the right retrofitting strategy. One medical device manufacturer achieved 84% connectivity on 30-year-old equipment just using simple low-cost IoT bridges. Myth number 4. Smart factory implementation takes years before showing value. The reality is, when done correctly, each phase should deliver measurable value within 90 days or less. A pharmaceutical company saw a 17% reduction in the batch release time within 60 days by simply digitizing their batch record process, long before implementing more advanced capabilities. The truth is that becoming a smart factory is an evolution, not a revolution. Every manufacturer, regardless of size or industry, can and should be taking steps towards this future. Now let's talk about how to actually get started with your smart factory transformation. Here is the roadmap I learned from my past experience, which is proven effective across the different industries. Step number 1, start with a business problem, not a technology. Begin by identifying your most pressing operational challenges. Is it quality issues, lengthy changeovers, poor OEE? Start with a problem worth solving that has measurable business impact. Step number 2, create your digital use cases. Define a specific use case that address your business problem. Be precise about what data you need, how you will capture it, and most importantly, or what decisions will be made differently with this information. Step number 3, form a cross-functional team. Smart factory initiative fail when they are siloed in either operations or IT. Create a team that includes operations, engineering, IT, and quality. The diversity is crucial for identifying the practical solutions. Step number 4, establish your connectivity foundation. Start by connecting your most critical assets to capture the data needed for your use cases. Don't worry about connecting everything. Focus on the 20% of the equipment that drives 80% of your value. Step number 5, implement, learn, and scale. Roll out your first use case within 60 to 90 days. Measure the impact. Learn from the implementation and then scale to the next highest value opportunity. This iterative approach builds momentum and credibility. Here is a real example. A contract manufacturer I worked with started simply by connecting their top 5 constrained machines to capture the downtime data. They visualized it on a simple dashboards and implemented daily review meetings. Within 45 days, they reduce unplanned downtime by 32% just by having visibility and accountability before implementing any advanced analytics or automation. This approach works because it delivers quick wins while building the foundation for more sophisticated capabilities. Remember, smart factories are built incrementally, not all at once. So, the path to becoming a smart factory isn't about technology, it's about vision, strategy, and execution. Start small, focus on value, and build incrementally. If you found value in this approach, please hit the subscribe button and notification bell to get more content on manufacturing excellence and digital transformation. So, what is your biggest challenge in moving forward with a smart factory? Drop it in the comments below and I will personally respond with the targeted recommendation. Thank you for investing this time with me today. Remember, the smart factory journey is a marathon, not a sprint, but you need to take that first step. Until next time, this is Nikhil Pal, helping you bridge the gap between manufacturing reality and the digital possibility.